Hello everyone. In this video, I will explain what is principal square root of a non-negative real number. Many students feel little difficult in understanding of the actual definition of principal square root or square root of a real number. So here you see a non-negative real number, a non-negative real number. Non-negative means it must be greater than or equal to 0. Y, a non-negative real number y, is called principal square root. The word is there, that principal square root, or sometimes we simply say that it is a square root of another non-real number x greater than or equal to 0. If we write that, you see, a non-negative real number y is called principal square root of a real number x. If we have that y square equal to x, if y square equal to x, then we call that y is the principal square root of x. Symbolically, we write that y equal to root x. Symbolically, we write this as y equal to root x. Here, I have used one symbol. This is the symbol, right? So the symbol, this one is called a radical sign. It's called a radical sign, or you can say this is a square root. We read as square root. Square root. So once again, I'm reading a non-negative real number y is called principal square root or simply square root of x greater than or equal to 0. Remember, we do not take any negative real numbers. If y square equal to x, then we write y equal to root x. See here that RHS1 is also greater than or equal to 0. And y is also greater than or equal to 0. So for example, so here I'll give one example that what is square root of 1? We write 1. What is square root of 4? We write 2. So here this is nothing but, here you see 2 square equal to 4. When this and this means inside the root and the output both are greater than or equal to 0, then we write like this. Similarly, what is square root of 9? This is equal to 3. Many students may think that square root of 9 equal to plus or minus 3. That is absolutely wrong. So here the wrong interpretation is, if we write that root 16 equal to plus or minus 4, this is wrong. So the output of square root of any non-negative real number is always a non-negative real number. So that input is greater than or equal to 0 and the output is also greater than or equal to 0. So therefore, square root of x equal to 5. This must be greater than or equal to 0. And this output is also greater than or equal to 0. This implies we can also write that y square equal to x. When we know in advance that y is greater than or equal to 0, x is greater than or equal to 0, then we can write this as a if and only. So this sign is a very important. We will apply frequently in exponential laws. in exponential loss. So therefore, that square root of 16, square root of 16, writing plus or minus 4 is absolutely wrong. Then what else we can write? Square root of a square, square root of a square, we write as this is a if we know that a is greater than or equal to 0. And this is minus a if we know that a is less than 0. Because the output, the square root of non-negative real number is always greater than or equal to 0. It will never be negative. It will be never be negative. So here I am writing one example. That square root of, suppose if you write minus 2 whole square. So minus 2 whole square is nothing but square root of 4. So it becomes non-negative integer. So the output becomes 2. So this is nothing but here it is negative. So here if a is negative, you keep another negative before that real number. So here minus of, we'll write minus 2. That becomes 2. If a is greater than or equal to 0, nothing will happen. So square root of 2 square equal to, directly you can write this is 4 and this is equal to 2. Here 2 is greater than or equal to 0. Here minus 2 is negative. So square root of a square we write equal to a if we know that a is greater than or equal to 0. And it is minus a if a is less than 0. In other ways, that square root of a, in other ways, square root of a is also written as square root of a square. In other ways, we write this as modulus of a. This is modulus of a. Modulus of a. Now I will explain that what is nth root of a. Here you see, let m comma n be positive integers. The nth root of a belongs to R, denoted by the nth root of a belongs to R is denoted by like this, nth root of a. This is equivalent to a to the power of 1 by n. A to the power of 1 by n. So now we can write here this restriction on a depends upon the value of n. Restriction on a depends upon n. So therefore, what we can write now, square root of a. We can write that a to the power of 1 by 2. This will be defined only when a is greater than or equal to 0. So here we don't write 2 in case. Actually, it is not necessary. Square root writing like this is same as this is nothing but square root of. Need not to specify this. Similarly, cube root of a. We write that a to the power of 1 by 3. Here you can take a is any real number. A to the fourth root of a. Fourth root of a equal to, we write a to the power of 1 by 4. Okay. See here I am going to explain that this is equal to, assume some value b. Now rising power 4 both sides. Rising power 4 both sides using that exponential loss whole to the power of 4 equal to b to the power of 4. This implies we can write that a equal to b power 4. So b power 4 is never negative. So it is always greater than or equal to 0, right? So this implies a must be greater than or equal to 0. So we can derive in this way that if a is greater than or equal to 0, then a to the power of 1 by 2n is defined. A to the power of 1 by 2n is defined. For example, what is 16 to the power of 1 by 4? Right? The output is always positive. Remember, the output is always positive. So its value is 2. Its value is 2. It is 2 to the power of 4, 4 to the power of 1 by 4. I can write this 16 to the power of 1 by 4 equal to 2 to the power of 4, power 1 by 4. That using exponential laws, I can write 2 to the power of 4 into 1 by 4. So this 4 cancelled. You will get 2 to the power of 1. It is 2. So a to the power of 1 by 2 power n is defined, and we write that a to the power of 1 by 2 power n equal to, we can write 2n the square root of a. Right. Suppose assume this is b, then this I can write a equal to b to the power of 2n. Okay. So here this is b square whole to the power of n. It is always greater than or equal to 0, right? So therefore a is greater than or equal to 0. Here input is greater than or equal to 0 and output is also greater than or equal to 0. The output is also greater than or equal to 0. The next one is if a belongs to R for any real number R. If a belongs to R for any real number, then a to the power of 1 by 2n plus 1 or 2n minus 1 is defined. Is defined. Okay. So here you see that a to the power of 1 by 2 power 2n minus 1. It is an odd integer. It is an odd integer. So this we write 2n minus 1 the root of a. Right. For example, here is an example that what is cubed root of minus 1. That cubed root of minus 1 is minus 1. Similarly, cubed root of minus 8 equal to minus 2. And that cubed root of 125 equal to 5. So observe, if the input is greater than or equal to 0, output is also greater than or equal to 0. If the input is less than or equal to 0, the output is also less than or equal to 0. So assume this is equal to some b. Let a to the power of 1 by 2n minus 1 equal to some b implies. Now rising power 2n minus 1 both sides. 1 by 2 to the power of 1 by a to the power of 1 by 2n minus 1 power. I am rising both sides power 2n minus 1. So b to the power of 2n minus 1. So left side you will get a. So this implies left side you will get a, and whereas right side you will get b to the power of 2n minus. Now observe that what is minus 2 whole to the power of 3? You will get, you have to multiply minus 2 3 times, so you will get minus 8. And minus 2 whole to the power of 4. You see, this you will get 16. And 3 to the power of 3, you will get 27. So when power is odd, if you give the input is negative, output is also negative. When power is odd, if you give input positive, output is also positive. Of course, non-negative. So this is nothing but you will get this is greater than or equal to 0 if b is greater than or equal to 0. Which means that this implies if a greater than or equal to 0, then a to the power of 1 by 2n minus 1 is also greater than or equal to 0. And now a equal to b to the power of 2n minus 1, it is less than or equal to 0 if base is negative. If that base is negative, or you can say less than or equal to 0. So in this case, that output is also less than or equal to 0. So this implies if a is less than or equal to 0, then a to the power of 1 by 2n minus 1 is also less than or equal to 0. So I'll give a few more examples. What is cubed root of? Okay, minus 64. So here the input is negative, right? So you can write this as a minus 4 cube whole to the power of 1 by 3. You bring out that negative sign. So 4 cube power 1 by 3, that you will get minus 4. Similarly, if I ask what is the fifth root of, let us take minus 2 whole to the power of 5 or 2 to the power of 5. So here the base, this is the positive. So you will get the output is 2. The output is 2. So finally, another point is left, that is when we have a to the power of m by n, let a greater than 0. Okay. Then or a is greater than or equal to 0, a to the power of m by n. We write that this as a to the power of 1 by n into m. Using that exponential laws, I can write this as a power m whole to the power of 1 by n. Okay. So further this I can write nth root of a power n. Nth root of a power n. Or else there is another way to express this, that a to the power of m by n. Remember, this is a very, very important, that how do we write that nth root of a power m? Nth root of a power m is nothing but a to the power of m by n. This also can be written as a to the power of, here you see, 1 by n into m a to the power of 1 by n power m. So this is nth root of a whole to the power of m, whole to the power of m. So therefore, a to the power of m by n is expressed as in two ways, you see, that is nth root of a to the power of m or nth root of a whole to the power of m. So problems will be complicated when problems involves this kind of mathematical operations, a to the power of n by n. For example, here I am writing one example. What is cubed root of? Okay, 2 to the power of 5. So we write that 2 to the power of 5 by 3. Another example. What is fourth root of? What is fourth root of? Let us take 3 to the power of 3. So we write 3 to the power of 3 power 1 by 4. Everything is exponential laws. Everything is application of exponential laws. So this we can write 3 to the power of 3 into 1 by 4. So this is equal to 3 to the power of 3 by 4. So I'll explain, I'll give some more examples based on this fact that a to the root over 2, root over, there are 2 square roots. Okay, so I'll write root over, this is 2 to the power of 1 by 2 equal 2 to the power of 1 by 2. Again another square root is there, so that I'll write again 1 by 2. So using that, a to the power of m whole to the power of n equal to a power mn. This exponential law is very, very important. So I can simply multiply these two. So 1 by 2 into 1 by 2. That gives 2 to the power of 1 by 4. So if we have two nested square roots, so these are known as nested square roots. I'll write here another example. Square root of square root of square root of. Okay, this is equal to 2 to the power of 1 by 2 square. Now I have taken here a, for example, a. Okay, where a is greater than or equal to 0. So this is equal to, first you know that when we have a two square roots, this is 2 to the power of 1 by 2 square. So I can write directly a to the power of 1 by 2 square power, that outer square root is there, that is 1 by 2. So this is nested square roots, nested radical sign. One by one inside the other. So using that same concept, a power m whole power n, we write a to the power of mn. So a to the power of 1 by 2 square into 1 by 2. So this gives a to the power of 1 by 2 cube, where a is greater than or equal to 0. So when nested radical appears only 3 times, then we write a to the power of 1 by 2 cube. So in that way, when it happens n times, square root of, square root of, square root of, and so on, here square root of a. So n times. This square root repeats n times. Simply we just write a to the power of 1 by 2 to the power of n, where a is greater than or equal to 0. In the next video, I will explain a few examples. And I'll give you one more example, that, for example, fourth root of a to the power of 3 by 5. So we write this as a to the power of 3 by 5 whole to the power of 1 by 4. Again a power mn formula. So a to the power of 3 by 5 into 1 by 4. So this is equal to a to the power of 3 by 20. See, when denominator is even, you must take care that a must be greater than or equal to 0.